The URL in the browser usually starts with HTTP or HTTPS. What is S here, and is there any difference? When we open the web page, the requested information must first enter a hierarchical model, which is transformed from top to bottom. Finally, the information is sent out at the physical layer. This is done on the client side. The receiver, such as the server, also receives information at the physical layer, and then gradually transform it upwards, get the initial information. These are also done in the server. Then, the protocol represented by the HTTP connection is an application layer of protocol used to transmit information such as web pages. Then, the S after HTTPS refers to the TLS standard, which is based on an encryption protocol called SSL. These two almost refer to the same encryption method, and we will refer to it as the SSL protocol. So the HTTP protocol is in the upmost application layer, and where will the SSL encryption protocol be? Let's introduce some background first. Around the 90s, most websites only used HTTP and were not encrypted because encryption requires additional calculation and transmission time. However, at that time, e-commerce websites began to rise, and more secure network communications were needed. Therefore, in 1995, Netscape, as the leader of the browser industry at that time, introduced the SSL encryption protocol for this. Although the company's prosperity did not last long and was robbed the throne by Microsoft Internet Explorer, the SSL protocol has been widely used by major browsers to this day. Then the SSL protocol adds a security layer between the application layer and the transport layer of the original model. After all, it mainly serves the HTTP protocol of the application layer. Then HTTP with SSL security layer is HTTPS, that is secure HTTP. So is there any harm in unencrypted HTTP transmission? When we are browsing the web, the browser is transmitting data with the server. There may be hackers eavesdropping on the information in the middle. So if the data is not encrypted, it will naturally know the content of the transmission. There are hidden network security risks. After being encrypted, it becomes a string of gamble transmission. Without the key, it is almost impossible to know what the original text is. Only when both parties have the key can communication be performed. Therefore, most websites now use HTTPS, like this logo in Google Chrome. The website is SSL encrypted. So this video mainly introduces how the encryption protocol is encrypted for transmission. It's mainly divided into two parts. One is the establishment of a secure connection, another is transmission of encrypted information. The first is to establish a secure connection. In the first step, the browser sends the SSL version that it wants to encrypt, the corresponding parameter preference, and a temporary value RA to the server. After receiving it, the server starts to reply with the SSL version and a temporary value of RB. Then the third step, the server sends a certificate which contains a public key signed by an authority. The browser verifies the public key in the certificate to verify the server. The fourth step is to send the end signal, and it is the browser's turn to continue sending. In the fifth step, the browser selects a random pre-mastered key and encrypted with the public key sent by the server and sent to the server. After the server receives it, now both parties have RA, RB, and the pre-master key. Based on this, the final encryption key can be calculated, which is called the session key. This key does not need to be transmitted. Therefore, in the sixth step, the browser informs the server that both parties use the calculated new key to continue communication. The seventh step is to send an end signal. Now it's the server's turn to send. In the eighth and ninth step, the server replies to the notification of changing the key and sends an end signal. This is all the steps to establish a secure connection. Next is the transmission of encrypted information. The two parties use another communication protocol. Specifically, the data to be transmitted each time is segmented first. Each segment is 16 KB in size, can be selectively compressed. Then add the message authenticate code at the end. It is like a fingerprint of this piece of information which is unique. Next, encrypt. Finally, add header. The segmented information encrypted in this way can be further transmitted to the transport layer. Well, I just introduced the main content of the SSL security protocol in detail. In fact, this involves asymmetric encryption, certificates, public keys, and other knowledge concepts of network security. We'll introduce it gradually in the future videos. Alright, this video is over here. See you in the next issue.